So I'm going to change this example up a little bit and put a 0 on the right hand side instead of a 1. So then if we look at our quadratic surfaces sheet, we have a couple possibilities here. We've got, well, all of these exponents are squared here. So anything that's got a 1 on the right hand side here is going to be out. Here we've got z to the first power, that's going to be out. Elliptic cone is a possibility because if you move the z squared over on the right, you'd have a 0. And then hyperbolic paraboloid, that would be out too because it's z to the first power. So this has to be a elliptic cone. And so let's go ahead and put it in our standard form here, solve in for the one variable. So in this case, x and z are negative, so we'll bring those over and solve for the y squared. So putting this in standard form, then y squared is going to equal positive 16x squared plus z squared. And we'd like to solve for the y squared, so let's divide the 4 off on both sides. So then we get y squared equals 4x squared plus z squared over 4. And then we're almost in standard form here. We would take the 4 here downstairs in the denominator and write it as a division by 1/4. And then write those denominators as squares. So our standard form here will be y squared equals x squared over 1/2 squared. We'll give our 1/4 plus z squared over 2 squared is going to give our 4. So next we will find our intercepts. So if x and y are both equal to 0, then this is going to 0 out, this is going to 0 out. So we will get 0 equals z squared over 2 squared, or z squared over 4. Multiply both sides by 4. You'll get z squared equals 0. And so z is equal to 0. So when x and y are equal to 0, z is equal to 0. So x, y, and z intercept are all at 0, 0, 0. So if you were to plug this one in, x and z equals 0, you would get y equals 0. And plug y and z in, you would get x equals 0. So intercepts are all at the origin. Traces now. So let's look at some traces. Z equals 0, plus minus 1, y equals 0, plus minus 1, and then same for x. So our traces here, oh, and this was elliptic cone. So if z is equal to 0, then this last term is going to drop off, and you're just going to get y squared equals x squared over 1/4, or x squared over 1/2 squared, which is the same thing as 4x squared up top. And so then if you take square roots on both sides, so you got your y squared is 4x squared. Take square roots on both sides, and that will give you y equals plus or minus, because you got positive and negative square root, 2x would be square root of 4x squared. So those are intersecting lines at the origin. Oh, in this cone, the y squared is positive, so it's going to be elliptic cone, and it's going to be along the y-axis. Right, because opens along the axis with the opposite sign. So and if we go back up here, the opposite sign is the y. If z is equal to plus or minus 1, That'll both be the same here, so that'll give a 1 in here for z squared. So then this will be y squared equals 4x squared, or x squared over 1/4, and then we'll have plus 1/4 here, because the z squared is 1, and 2 squared in the denominator, 1/4. So then we want to go ahead and bring this over on the left-hand side. So we will have a negative 4x squared plus y squared is equal to 1/4 on the right. And then multiply through by 4 to make that 1/4 a 1. Put this in standard form. So this will be a negative 16x squared plus 4y squared is equal to 1. And that is a hyperbola. If both signs were positive, you'd have an ellipse. One sign's negative, you got a hyperbola. And it's going to open along the y-axis. And so that's at z equal plus or minus 1. If y equals 0, this term drops out. So you just get 0 equals x squared over 1/2 squared. And plus z squared over 2 squared. So then what we've got is this term is non-negative, this is non-negative, and they add together to give 0. The only way that can happen is if x equals z equals 0. So your trace is just one point at the origin, and it's the point of all the intercepts. Y equal plus or minus 1. So we put plus or minus 1 in here. Squared will be a 1 on the left-hand side. Then you've got x squared over 1/2 squared. Oops. Plus z squared over 2 squared. And all the signs are positive here. That is going to be an ellipse. It'll go plus or minus 1/2 in the x direction, plus or minus 2 in the z direction. And then let's grab this equation so we can bring it down. Put it right there. And then if x is equal to 0, then this term will drop out. And we'll just have the y squared and the z squared left. So this is going to give us y squared is equal to z squared over 4. Take square roots on both sides. And you get y is equal to plus or minus z over 2. Or if you wanted to solve that for z, multiply both sides by 2. This is equivalent to z equals plus or minus 2y. And again, those are intersecting lines. These are lines. I did mention these were lines. And then that last trace, x is plus or minus 1. That just makes this a 1. So that gives us y squared on the left. And then a 1 over 1/4, which is 4, plus z squared over 4. And so let's bring this z squared over as a negative on the left-hand side. So we've got y squared minus z squared over 4 is equal to 1 divided by 1/4. Reciprocal 1/4 is 4. And then we've got to divide everything by 4 here to get our standard form. So this will be y squared over 4 minus z squared over 16 is equal to 1. And that's another hyperbola. So, and we could do the sketching here. We'll just do a rough sketch here real quick. We've got z, y, and x. And this guy is going to open along the y-axis. and it's a elliptic cone. So our y-axis is right here, x is here, z is here. So it's going to be looking something like this. It's going to open like that along the y-axis. So we just need to figure out what it looks like. And to do that, we want to look at our y constant cuts here. So y is plus or minus 1. So we had, say, 1 is here and negative 1 is there. And those were ellipses that went 1/2 plus or minus 1/2 in the x direction and plus or minus 2 in the z direction. So out here, if I went up 1, 2, so right there, and down 1, 2, right here. And then this way it's skinny, so it only goes 1/2. So 1/2 in this direction and 1/2 in that direction. So we got these skinny ellipse cross sections, which would look like that. And then we'd have another one of those over here at -1. Get my circle tool again. So look something like that. And then those intersecting lines, the intersecting lines here, y is plus or minus 2x, right here and right here. And then the intersecting lines down here, z is plus or minus 2y. I'll draw those in black. Whoops. Get that line in blue. And then in black, I will do the other two. So those are going to be from here to the opposite side over there, and then from here to the opposite side over there. So those are in the YZ plane. Or let's see here. That's X and Y. These are YZ here. I'm sorry. So Z equals plus or minus 2Y are the blue ones. And then the black ones, those are the y equals plus or minus 2x. So I'm joining these points here that are in the xy plane. Let's see, actually, I guess the way I've got this joined, this should go over, and this one shouldn't from the view that we're looking at. Yeah, so there we go. All right, very good.